Lecture 2 of 5, Topic 5, Vector, Subtopic, Vector Product. Learning outcome. At the end for the lesson, students should be able to A. Find the vector product. B. Use the property of vector product. C. Find the area of parallelogram and a triangle. Vector product. The vector product or cross product of two vectors A and B is defined as A cross B equal to magnitude A, magnitude B, sine theta with vector U, where the theta is the angle between vector A and B and U is the unit vector in the direction of A cross B. From diagram, we know that vector A cross B is perpendicular to both vector A and B. Also, vector B cross A also perpendicular to both vector A and B. The relationship between vector A cross B and vector B cross A is vector B cross A is negative of vector A cross B. If we want to find the vector is perpendicular to both vector A and B, so we just need to find vector A cross B. If vector A cross B is equal to 0 vector, this means that vector A and vector B are parallel. The vector product of vector A is equal to a1i plus a2j plus a3k and vector B equal to b1i plus b2j plus b3k can be expressed as determinant form, where the first row is the component of ijk, second row is the coefficient of ijk from the vector A, and third row is coefficient of the ijk for vector B. So if we expand the first row and first column, so we will get this A2 B3 minus A3 B2 for component I, and then minus eliminate the first row and second column, we will get A1 B3 minus A3 B1 for component J, and eliminate the first row and third column, we will get this A1 B2 minus A2 B1 for component K. Note that vector product for same component will get the 0 vector. For example, I cross I is equal to 0 vector, J cross J equal to 0 vector, and K cross K is equal to 0 vector. The cross product for different components can show as the diagram below. The order is crosswise. For example, we will get I cross J is equal to K, J cross K is equal to I, and K cross I is equal to J. If the order is anti-crosswise, so we will get the negative sign. For example, J cross I is equal to negative K, K cross J is equal to negative I, and I cross K is equal to negative J. Example 1. Given vector A is equal to 2i plus 3j minus 2k and vector B is equal to 4i minus 2j plus 3k. Find vector A cross B. So first, vector A cross B we can represent in the determinant form, where the first row is component of ijk, second row is coefficient of ijk for vector A, and third row is coefficient of ijk for vector B. And then want to expand, if we expand along the first row and eliminate the first row and first column, so we will get 9 minus 4 for component I. Eliminate the first row and second column, we will get 6 plus 8 for component J, and eliminate the first row and third column, we will get negative 4 minus 12k, and simplified we will get is 5i minus 14j minus 16k. Example 2. Find the unit vector perpendicular to vector A is equal to 4i minus j plus 3k and vector B equal to 2i plus 3j minus 2k. So we know that vector perpendicular to both vector A and B is vector A cross B. So vector A cross B, we can represent in the determinant form, where the first row is the component of ijk, second row is coefficient of ijk for vector A, and third row is coefficient of ijk for vector B. Expand the first row and first column, so we will get 2 minus 9 for component I, and then minus, expand the first row and second column, we will get minus 8 minus 6 for component J, and eliminate the first row and third column, we will get 12 plus 2 for component K, and simplified, we will get negative 7i plus 14J plus 14K. But the question is want to find the unit vector. So we know that formula of unit vector is vector divided by its own magnitude. This means that we need to find the magnitude first. Magnitude of A cross B is equal to square root of negative 7 square plus 14 square plus 14 square is equal to 21. Next, we find this unit vector. Unit vector is vector divided by its own magnitude. So it's vector A cross B divided by magnitude of A cross B. So it's equal to 1 over 21 times negative 7i plus 14j plus 14k. So this we can factorize and simplify. So I factorize 7 over 21 we get 1 over 3. So it's equal to 1 over 3 times negative I plus 2j plus 2k.